Welcome to Engenius Films, sharing the genius of engineering. Engineers are always coming up with new designs and clever inventions, but someone's got to work out how to make them.
Well, here at the AMRC, the Advanced Manufacturing Research Centre, engineers and scientists are doing that, working out what is the best way to actually manufacture these things.
First, here's Johnny from the Process Technology Group.
The Process Technology Group is concentrating mostly on subtractive manufacture, which is the removal of metal by milling and turning. I work with low carbon vehicle technologies, vehicles which use less petrol or electric vehicles or other novel technologies such as hydrogen fuel cell vehicles. As vehicle technology gets more and more advanced, the components within the vehicles become more difficult to make. We concentrate on making them cheaper and more environmentally friendly. There are a range of materials that we use, such as aluminium for the gearbox behind me, ranging through to titaniums, which are very hard to machine, so tool selection is very important. We're running machinability trials to find out how to make the parts cheaper. This behind me is a vertical mill, which uses a very hard spinning tool to remove material. We deal with a whole range of components from engines, gearboxes, turbochargers, superchargers, and the aim of all this is to make more efficient vehicles.
But even metals like aluminium and titanium have some stiff competition.
Sometimes it isn't always the right thing for the job. You might want to have something that's lighter, possibly stronger in a different way, and that's where composites can help.
Composite materials are lightweight materials that are made up of more than one material. The combination of those materials means that the properties are better than any of those materials alone.
Composite materials are taking the best of two worlds and melding them into one.
A metal, for example, has properties that are the same in every direction. A composite material is designed to have specific properties in specific directions.
An example of a composite material is a glass fibre reinforced plastic. So that's glass fibres that are in a plastic material. You take this glass fibre and you can inject a resin or a liquid plastic essentially throughout the fibre, and then you can cure it in an oven or a pressure oven, and that gives you composite material. A plane that you might take on holiday, a great deal of that might be made using a fibre reinforced plastic, so whether it's the tail fin or the wings itself or part of the undercarriage, different parts might be used to reduce weight.
Weight is important because the biggest cost of running an aeroplane is the fuel. So every gram on your plane means that you're burning extra fuel over the life of the plane. That's why there's a constant drive to reduce the amount of material. Composite materials allows you to reduce the weight.
So an example of some fibre reinforced composites is this part of a fuel tank for an aircraft. So this has a layer of carbon fibre reinforced plastic on the inside, followed by an aluminium honeycomb structure in the middle, and another layer of carbon fibre reinforced plastic. So that gives you two really strong layers of plastic with fibres in them to really give you some rigidity. And you've got this material in the middle which gives you the extra bending stiffness. So the thicker that is, the stiffer it will be. And that's exactly what you want when you've got more than a ton of liquid sloshing around inside there. For Formula One, lots of their cars these days do use fibre reinforced plastics, whether it's in the spoiler or the air intakes or part of the chassis, and all that's to reduce weight. Composite materials are good at reducing weight, partly because of how they can take the best properties of two or more different things, and it has a lower density, so it weighs a lot less.
From getting the machining of parts of electric cars just right, to finding ways of incorporating more composite materials into aircraft, engineers are finding ways of making sure that the transportation of the future won't cost the Earth.